This is the NEC MultiSync 3D, and it could just be one of the most versatile RGB monitors. That is, if it even works. Hi, I'm Matt, and welcome to episode 97 of Retro Bits. In the last episode, I went to a big VCF swap meet in New Jersey. At the very first table, I found something I've been on the lookout for years without luck. The seller said it had issues, but for $20, I simply couldn't pass up the opportunity. The monitor in question is the MultiSync 3D by NEC. We'll look at what makes it special in a moment, but on the surface it looks pretty typical. Featuring a 13-inch viewable CRT and a maximum resolution of 1024 by 768, you'd be forgiven for writing this off as just another early desktop VGA display. Launched in 1989, the MultiSync 3D sold for around $650 US, or $1,600 adjusted for inflation. Have you spotted anything unusual about this monitor yet? Personally, I like the design quite a lot. The NEC is handsome and looks modern for 1989. It's exactly the sort of thing you'd picture in your head when thinking the words CRT computer monitor. This particular example is filthy and has a few blemishes, but what's really important lies beneath the surface anyway. Enough teasing. What's so special about this thing then? Better service, better reputation, better profit, obviously. Okay, no. Let's take a look at the specs in the service manual. First of all, the 3D supports both digital TTL and analog RGB. It also doesn't care whether you feed it separate HV sync, composite, or sync on green. It even handles horizontal refresh rates from 15 to 38 kHz, meaning it can sync down to 240p sources. Truly a universal RGB display then, and well known in the Amiga circles, which is how I first heard about the model. Very few displays support MDA, CGA, EGA, VGA, and Macintosh graphics due to how different the formats are from each other. It also supports non-standard resolutions. Does that mean it could work with the X68000's oddball refresh rates? I guess we'll find out. Alright, so first impressions? Well, the monitor is in generally pretty good condition. It does have some nicks and scuffs in the plastic, but nothing to indicate that it's ever been dropped or suffered any kind of serious physical trauma. That said, there is a significant amount of dust and dirt both on the screen and on the plastic bezel, indicating that it's been stored in a garage or an attic and exposed to some elements perhaps. But we'll get it cleaned up right away. That'll be one of the first things that we do. You may have already noticed that the little trapdoor covering up the digital controls is missing, so we may be able to 3D print something, but I doubt I'm going to get a very good color match with this gray here. In terms of the digital controls, we have a factory reset button, vertical position, vertical size, horizontal position, horizontal size, 8/16 and 64 color, and monochrome mode switch for TTL RGB, as well as contrast and brightness controls. The MultiSync 3D has an onboard 1KB EEPROM memory for storing display size and location for up to 29 unique screen modes. Here on the underside of the monitor, we have the manufacturer's label with the model number and serial number, as well as the manufacturing date of February 1991. Now, I thought this monitor was a late 80s model, but clearly it is an early 90s model instead, so a bit newer than I thought it was. There's also this second larger sticker on the underside, again with the model number here and the manufacturer date of February 1991, and it also says that this monitor was made in Japan. Also here on the bottom is this tilt and swivel base, which gives the monitor quite a range of adjustability. Now, when you buy a used display, oftentimes the bases are missing, so I'm really happy that this was included in this $20 purchase. Here around the back we have a standard IEC power connector as well as an HD15 video cable. Now some versions of the MultiSync 3D had a DB15 video cable for use with some Macintosh computers, but fortunately this one came with the standard VGA style connector, so we don't have to build an adapter. Oh yeah, that cleaned up real nice. Now with the easy part out of the way, let's see what's actually wrong with this thing and if it can be saved or not. At the swap meet, the seller indicated that there was a problem with the image being compressed on the screen, a common failure mode in older CRTs known as collapse. I'll turn the brightness and contrast all the way down before powering on the unit. A collapsed raster can easily burn a line or spot into the center of the display, and we want to avoid that. I can feel static, so the monitor is making high voltage. That's a good start. Next, I'll connect up a source and bring the brightness and contrast up slowly so we can see what we're dealing with here. Okay, it looks like we have partial to total vertical collapse. That could be caused by a number of issues. First, it could be the result of bad power regulation. That's easy enough to diagnose, and I'll test all the voltage rails to rule that out. The second possibility is a failed vertical deflection IC. I don't think that's the case because the problem is variable, ranging from a nearly complete image to total collapse. Let's not rule it out though. Third, we could have a cracked solder joint. I'll try a little percussive maintenance to see if the image flickers or not. Nope. Next, we could have a damaged deflection yoke. There hasn't been any smoke or sizzling, so we're not dealing with a shorted coil. And again, the problem is variable, so I think we can rule that out as well. There could also be a failed or failing transistor or passive components in the vertical deflection circuit. And finally, and you knew this was coming, the ubiquitous old capacitors. My hunch is that we should start with the caps. The longer I leave the monitor running, the better the image becomes, up to a point. I suspect it's because the capacitor's anode oxide layer has decayed over time due to disuse. If the electrolyte hasn't completely leaked out, the layer can reform once voltage is applied, and I think that's what we're seeing here as the image improves on its own. Alright, let's get this thing opened up for diagnosis. I'll spare you the disassembly montage this time. I'm just following the procedure exactly as stated in the service manual. Just a reminder, CRTs are dangerous. Don't open one up unless you know what you're doing. I don't, but these are the lengths I go to bring you quality YouTube content. With the cover removed, we can see what we're dealing with here. It's pretty tightly packed in this thing. There's not a lot of room to work with. I've never tried to repair a VGA monitor before, just 15 kHz units from the 80s up till now. How different can it be though, right? I guess we're about to find out. And through the magic of YouTube, everything is now disassembled. The monitor itself is relatively modular, everything came apart pretty easily, but there are just an absolute ton of wires connecting everything together. And for the most part, these wires are keyed, but a lot of them are the same size and shape as each other. So I did take pictures of everything before I unplugged them. And in some cases, I even marked which side is up. So I should be able to get the correct wire in the correct place with the correct orientation when it's time to put everything back together. Taking a look at the components now, let's start with this one. And this is called the sub board. And it actually does some of the video processing. It ingests the video signal, and then some of the functions that it performs are separating out the sync signals, decoding the digital RGB, and converting it to analog, among some other functions. Next up, we have the power board, and this one shows some signs of being reworked. It has this massive 820 microfarad 200 volt capacitor here, which has, I don't know if you can see it, but there's a green dot on the surface of it, and it looks like it may have been reworked in the past. There are a whole bunch of other capacitors on this board that do not have the green dot, so I'm guessing that the previous owner may have replaced some, but not all of them in the past. At the front of the chassis, there's a PCB that runs the entire length of the monitor that handles all of the digital controls. I'm not going to remove that because it looks like a huge pain to try and get out. And finally, we have the main board and the neck board. And the flyback is connected to the neck board, and it's not really easy to remove, so I've left them attached to each other. One thing of interest is the number of large transformers on the main board. In monitors I've worked with in the past, the flyback itself was what generated all of the voltages for the system, but I guess that's not the case for this monitor. Maybe it has something to do with the multi-sync nature of this display, but I don't really know. Now here's something I noticed. This main board is really filthy, and I'm not sure you can see it, but let me get you zoomed in here. And there's just a lot of discoloration, and it's not just the grime that's settled onto it. It looks like this may have been exposed to moisture as well. There's just a lot of grime that's really baked on, but it also could be like mold or something, I'm not sure. It just looks like this has been exposed to not just dirt and dust, but also moisture. And it may have come through the top vents of the monitor and settled out here on the main board. The other boards look a lot cleaner, but they were protected by the RF shield and they were mounted vertically, whereas this one was mounted horizontally. And it looks like it got the brunt of all the dirt and debris that settled in on this monitor. Now, I'd love to throw this in an ultrasonic cleaner and have it cleaned up real nice, but I don't have one big enough to handle this board. So what I'm gonna do is I'm just gonna use a brush and try and remove some of the loose dirt on here, but I'm not going to inundate this in water or anything like that. Yeah, simple brushing alone is not going to work. This is caked on. This is moisture or mold or something. So I would love to throw this in an ultrasonic cleaner. Maybe if we get this working, I will find a way to do that. In order to level up my troubleshooting skills, I'm not going to be taking the shotgun approach here. I want to try and narrow in on the problem logically first. Fortunately, the NEC service manual is excellent and has detailed diagrams of the various subsystems, including the vertical deflection, position, and size circuits. According to this, there are only 4 electrolytic caps. C418 appears twice, so let's start with them. Having looked at the service guide now, it's kind of hard to nail down where vertical deflection actually takes place on the board. Over here we have the vertical oscillator chip. This big package here is the vertical deflection IC. Over here we have a digital to analog converter package, which is part of the circuit. So what I'm going to do is I'm going to go through the service guide and find every capacitor on the board that's mentioned as part of the vertical circuit, and I'm going to mark them with this red pen. Then I'll come back and test each one of those capacitors separately. All right, and here are the results. First of all, there aren't that many electrolytics in the vertical deflection circuit. Most of them are actually ceramics, and there's one tantalum capacitor. So of the 4 that I did test, C418 has a spec of 1000 microfarads, and it tested out to 1034, which is well within tolerance. It also had a 0.08 equivalent series resistance, which is fine. C426 was 1 microfarad and tested at 1 microfarad and has a 3.9 ohm ESR, which is fine for a capacitor of that size. Now over here, 412, I was not able to get any reading at all on the testing tool, so I'm going to have to remove it from circuit and try it outside of the circuit to see if the capacitor is dead or if it just can't be tested in situ. And finally, C410 returned a 0.3 ohm ESR, but I was unable to get a capacitance reading, so I'm also going to have to remove that from circuit and see what's going on with that capacitor. So that's what we're going to do. All right, this is C410, and this should be 470 microfarads. Let's test it out now that we've got it out of the circuit. Let's see. Okay, 399 and a 0.27 ohm ESR. That's not terrible. Next up, we have C412, which is supposed to be a 100 microfarad capacitor. And remember, this one tested in circuit with no result at all. We couldn't even get an ESR or capacitance. So let's hook it up to our meter out of circuit and see what we've got. Open circuit, low capacitance. So this is a dead capacitor, and this one was the capacitor that was closest to the vertical deflection IC on the board. So this may be our smoking gun. I'm going to get a replacement for this one, and let's see if that solves our problem. Yeah, on closer inspection, check this out. This capacitor has definitely leaked out. There's corrosion all over the legs. There's a little bit of a bulging there, and it smelled characteristically of fish when I desoldered it. So yeah, this capacitor has leaked. As always, I like to mark off every capacitor that I've replaced with a Sharpie just so I know for the future when I come back and look at it again. And in testing, I noticed that C415, which is the next door neighbor to the bad capacitor C412, was also bad. It was the same exact make, model, and specification as C412, and it also had leaked out. Now, C415 doesn't appear in the vertical deflection circuit schematic, but since it was bad, I went ahead and replaced it anyway.
All right. Let's test out our modest repair and see where we're at now. I've added labels to all of the wires to take some of the guesswork out of reassembly. Could it really be that simple? Place your bets now. Huh, interesting. Despite how it looks, this is actually progress. Believe it or not, I'm happy with this result because the vertical is now rock solid and stable. It looks like the problem has cascaded down to the next failure, which is impacting the horizontal now. I'm willing to bet that since I already found a few leaky caps, it's likely there are a bunch more.
So, what now?
Okay, so we were able to use some educated guessing, the service manual, and the ESR tester to narrow right in on the vertical deflection problem and resolve it. Now we're faced with a choice. Do I do the same as before, this time with the horizontal circuit, or do I go with the shotgun approach and recap the entire monitor? The issue at hand is the hour it takes to disassemble and reassemble the monitor each time I want to test a single change, and how many cascading failures I'll have to resolve before it's fixed. It's probably quicker just to recap it all in one shot. Since I really want to save this multisync and plan to keep it forever, it's probably the right choice anyway. Time to go shopping. There are quite a few caps in this thing that I don't have on hand, so I'll order what I need and also a bunch of extras for the more common values. Ever tried buying capacitors before? For each capacitance and voltage rating, there can be dozens of options, many with nearly identical specifications. Repeating this process for each part needed sure can be time-consuming. Well, I bought a bunch, so we'll see how this goes. Stand by. Right, that's all 4 PCBs recapped. I ended up replacing 83 parts in total. In addition to the residue on the board, a handful of the caps had leaked, so I cleaned up as I went. If this fixes the monitor, I'd still like to send the PCB out for a proper ultrasonic cleaning to prevent future corrosion. Speaking of which, let me reassemble everything again so we can test out the repairs. What the fuck? It's exactly the same as before. Oh well, back to the drawing board. Sit rep. I've torn everything apart and put it back together 3 more times. I've checked all my work, then checked it again. I've tested voltage regulation, all of the passives and transistors in the horizontal circuit and didn't find anything wrong. After all that, the problem's only gone from bad to worse. Now the screen won't even turn on at all, it just makes a clicking sound. All that time and effort, and I've only gone backwards. I really thought this was going to be easy. Right, I've torn it all down again and inspected every single trace and solder joint. And would you look at that? There's no doubt in my mind that this is self-inflicted. I must have broken this joint by flexing the board during one of the times I removed or installed it in the chassis. Haha, great. We're back to where we started before the full recap. Did I really just waste all that time? If it's not the caps, then what? I did notice in the service manual that there were 2 variable potentiometers that control the horizontal hold. Could it be that simple?
And there was much rejoicing.
Oh my gosh, are you kidding me? The monitor was probably fixed after just replacing the 2 caps in the vertical deflection circuit at the very beginning. It's all good though. There were a lot of leaky caps that really did need to be replaced, so now it should be good for another 30 years. Now that we have a working display, how does it look? Actually, not bad at all. Convergence is quite good, but the geometry could stand to be tweaked. It definitely needs a pincushion adjustment. Yeah, that's better. The color is good without any adjustment. It does look better in person than on camera though. Did you notice the line across the middle of the screen? My guess is the previous owner ran it for a while with the vertical collapse and the screen is burned in a little. That's disappointing, but it's pretty minor, and for $20 I really can't complain.
Seriously, after all that time and effort, I really wasn't sure that I could save this thing. I was getting properly bummed out, so I'm super happy that it's finally working.
Now the real reason I've been looking for one of these for so long, and am thrilled to have finally found one, is the X68000. Up till now, I haven't had a display that would work with the system. Importing a genuine Sharp unit from Japan would cost over $1,000 by itself. I'm dying to see if the NEC can handle all the oddball resolutions and refresh rates the system puts out. Star Cruiser is one title that I know for certain switches between 15 and 31 kHz display modes mid-game. Sweet, look how smoothly the NEC transitions between resolutions. No flicker whatsoever. If you remember when I first got the machine and tried to use it with an LCD panel, the status bar on the bottom was cut off and I needed to borrow an expensive upscaler just to use the system. The NEC, on the other hand, shows the human 68K command line perfectly. Somehow, I missed this little built-in pinball game before, but SX Window looks great on the MultiSync as well. One last thing I want to try. Marble Madness is one of the handful of games that makes use of the X68000's 24 kHz video mode at a resolution of 336 by 448. Let's see how the NEC handles that. I think it's safe to say that this is the one-size-fits-all solution I've been looking for. But let's not limit ourselves to just this single machine. The MultiSync 3D is also the perfect complement to the Mr. FPGA's RGB output, and should work with the native resolution of just about all of the cores. Let's take a look at a few. Let's see what else this thing can do. I built this 9-pin adapter for digital RGB. I don't have an EGA machine, but we can test it out with CGA and Tandy graphics. So, how does the MultiSync 3D stack up to the mighty Sony PVM? Let's compare it to this 1342Q that I reviewed way back in episode 24. Both monitors feature 13-inch viewable screens, and both have 600 TV lines and a similar dot pitch. As the name implies, PVMs were designed for professional use in television studios and video production, and no expense was spared in their construction. The NEC was designed for professional use in an office environment, but consider that it died years ago and required servicing, despite being newer than the Sony, which is still all original. In terms of connectivity, the NEC only has a single input. It automatically detects and switches between TTL and analog RGB modes and resolutions. The PVM, on the other hand, has multiple inputs and outputs. It too supports digital and analog RGB, but also composite and S-video as well. The PVM sets the benchmark for the viewing of 240p and 480i content. It has a 0.25mm dot pitch using a Trinitron aperture grille. It can ingest just about any composite video format, including NTSC, PAL, and CCAM. A single mono speaker is available, but you probably won't use it for gaming. The NEC, on the other hand, has a 0.28mm dot pitch using a conventional shadow mask. This means that the tube is more curved than the Sony. As a computer monitor, there's no composite input and no speaker at all. What sets this particular multisync apart from most PVMs is that it isn't limited to displaying only 15 kHz sources. As we've seen, it can display VGA and Super VGA resolutions up to 1024 by 768. That means it will pair with a wider variety of vintage and retro systems, including PCs, the Mr. FPGA, X68000, and more. In terms of video quality, you won't be disappointed with either option. A shadow mask display like the NEC's has a different quality to it than the aperture grille of a Trinitron, but either way, you'll still be getting a super clear image and well-defined 240p scan lines. It really comes down to your preference, and personally, I love them both. Well, that was quite an adventure. I've got to say, this is a great little monitor, and I still can't believe I found it for such a bargain. Despite the setbacks, I'm thrilled with how the project turned out and hope to get many years of service from it. Fair warning, if you happen to come across one in the wild like I did, it will most likely need to be serviced if it hasn't been already. Coupled with how rare these are, you might be better off buying the nicest, newest CRT monitor you can find and using it with a scan converter instead.
So there we have it, the NEC MultiSync 3D. Is it an excellent monitor for RGB? Absolutely. Is it better than a PVM? Well, that depends on your individual needs. If you enjoy this type of content, please remember to like, subscribe, and leave a comment. Thank you so much for watching, and we'll see you next time on Retro Bits.